All right, guys, welcome back. We're talking again today about inferences. We said last time we'd take another look at this before we started on that assignment. So we're going to look at it again today. We'll look at some examples about inferences. Now, last time we talked about this, we mentioned populations, samples, and ultimately what an inference is. So first off, a population. Population, we said, was a group to be studied or analyzed. It's the entire population. So if you want to know about how, say, students in the school feel about cafeteria lunches, the entire population would be the entire student body, all the students that go to that cafeteria. But if you want to find out how students feel about that lunch, you're not going to ask the entire population. There's not enough time. It doesn't make sense. It's not feasible. So you find what's called a sample. Now, a sample is a subgroup of the population that is surveyed about a question or a topic. So these are the ones that you actually ask. You're not going to get every single student in the school. You're going to ask a small set. Now, hopefully we think that this sample is going to be what's a random sample. We'll talk about a random sample later on, what makes a sample random. But right now, let's assume that all the samples are random. Now, once we have this survey completed and we have the information from it, then we can make the inference. Now, the inference is a statement about the population based on information from the sample. So if you figure out that half of your sample really likes the cafeteria lunches, then you can infer that half of the entire population really likes the school lunches. Okay, now, it's not always going to work out nice and neat with the halves, but we can make inferences about the population using a pretty simple equation. And we mentioned this equation last time. What you do is you take the number of successes from your survey and you divide by the total number of people that you surveyed, the sample. Now that's going to give you a decimal. It's going to give you the percent of people in that sample that have that particular characteristic. So what you do then is you multiply that decimal by the population. And with that equation, with that division followed by the multiplication, that's going to give you your inference. That's going to tell you what you want to know about the population. Now, this is a whole lot like what we talked about a couple times ago when we were looking at frequency. So what we did was we took the probability that an event would occur. Well, guys, that's pretty much what this is. The number of successes divided by the number in the sample. Your number of successful outcomes divided by your possible outcomes. Same kind of idea. And then what we did was we took that probability and multiplied it by the number of times we do the experiment. Well, that would be the population. So we multiply that percent by the entire population, and that gives us how many times we can expect that to happen. Our inference about that population. Okay? It's pretty much the same equation. We're just putting some different language on it, a couple of different words, but it still means pretty much the exact same thing. So let's take a look at some examples. Now the first one, we've got a large high school with 3,000 students. And we have a sample, a random sample, there's that random sample again, of 75 students is surveyed about whether or not they have social media accounts. Of the 75 students surveyed, 5 did not have social media accounts. We want to estimate the number of students in the school that do not have social media accounts. So that's what we're trying to find. We're trying to make an inference. That's what we're trying to calculate. Now, we have a large high school with 3,000 students. That 3,000 students, that's the population. That's the entire student body. Then we have a sample of 75 students. So that's 75. That's the number in the sample. And of those 75 students, 5 did not have social media accounts. Now, I know not having a social media account does not sound like a success, but that's what we're looking for, so it is our success. It's the number of successes from our sample. So we'll use that equation. Success over sample times the population gives us our inference. Okay, so our successes were those 5. Our sample was 75. and there's 3,000 in the population. That will give us our inference. Well, if we do 5 divided by 75, we'll get 0.06 repeating. So if I multiply that by 3,000, not 30,000, just 3,000, we get 200. So we can infer that 200 students do not have social media accounts. Now the question's asked with a complete sentence, so we should answer it with a complete sentence. So we can say, they ask us to estimate the number of students in the school that do not have social media accounts. We estimate the number of students, or we estimate that 200 students do not have social media accounts. Okay, and don't forget to circle your final answer. Always circle the final answer. Okay? And there we go. That's all we need to do. Now, number 2 is just a little bit different. It's pretty similar, but it's a little bit different. Every month, an electronics company produces 7,250 virtual reality headsets. Last month, a random sample of 200 headsets showed that 2.5% were defective. How many defective headsets can the company expect to produce every month? Well, again, we're asked to infer about that population, about how many defective headsets they're going to produce. So our inference is what we're trying to find.
Pardon the interruption. All the students please report to the office. Brandon Tesler, throw it over.
So we want to make an inference about the entire population. That's what we're trying to find. So we need the population size. And we see that the population size, that's 7,250 total virtual reality headsets. Then we have the sample size of 200 headsets. And then we have this 2.5%. Now this is where it gets a little tricky, because usually last time we have the 5 successes. And we don't have 2.5 defective headsets, we have 2.5% defective headsets. So this is actually what we would get if we took our successes and divided by our sample size, which gets a little bit goofy, but it actually saves us a little bit of work. Okay, because remember, our formula is successes over sample size times the population equals that inference. Well, they're actually doing this whole part for us. We don't have to divide the successes by the sample because they gave us that. Now, there is one little catch, though. We've talked about before how we can't use percents in our calculations. We have to convert them to decimals. So remember the trick. Move the decimal point 2 spots to the left, and we can say, in place of this success over sample, 0.025 times our population of 7,250 headsets, and that will give us our inference. Now, if we come over to the calculator and we do 0.025 times 7,250, we'll get that our inference is 181.25. Now the question is asked with a complete sentence, so we should answer it with a complete sentence. Okay, how many defective headsets can the companies expect to produce each month? The company can expect to produce 181.25 defective headsets each month. But there's a little bit of a problem here. How are they going to produce part of a headset? They can't. The headset is either defective or it's good. So we're just going to round it. And we're going to say instead of 181.25, just 181 defective headsets each month. Okay, there's our final answer. Make sure we circle our final answer. The company can expect to produce 181 defective headsets each month. Okay? All right, let's flip over to the back. Let's take a look at one more that's like this. Okay, and then we'll look at one that's just a little bit different. So we have a large college with 36,000 students, and we have a randomly selected sample of 675 students who were asked how far they live from campus. 108 of the students surveyed lived more than 200 miles from campus. We want to estimate the number of students enrolled at this college who live more than 200 miles from campus. So we want to make another inference. That's what we're trying to find. We have a population of 36,000 students. We have a sample size of 675 students. And we say from that sample, 108 of those students say they live more than 200 miles from campus. That's our success. Our success is how many students live more than 200 miles from campus. Now, what we're going to run into a lot is this 200 miles. We're going to see a number like that and feel like, well, this is math class, it's a story problem, I've got to use every number that's in the story. But those 200 miles, they're not really part of the statistic. They're not part of the calculation. They're just part of the description of what that characteristic is. So those 200 miles aren't going to be part of our calculations. They might be part of our final answer, but they're not part of our calculation. So let's build our equation. We want to do successes divided by the sample size. We want to multiply that by the population, and that will give us our inferences. Well, our success, we said, was 108 over our sample size of 675, and our population is 36,000. And that will give us our inference. So first off, let's follow order of operations, and let's divide 108 divided by 675, and we'll get 0.16. So I have 0.16 times 36,000 will give us our inference. So take that 0.16 and multiply by 36,000, and we'll get 5,760 students. Five. Okay. Now our question is asked with a complete sentence, so let's answer it with a complete sentence. They want to know how many students enrolled in this college live more than 200 miles from campus. We can say about 5,760 students live more than 200 miles from campus. Okay, and don't forget to circle your final answer. Okay? So we have 36,000 students in the population, got a sample of 675, 108 of them live more than 200 miles from campus. So 108 over 675 times 36,000 gives us 5,760. Now, we can also use this same procedure to estimate population. We don't necessarily have to solve for the inference. Sometimes we want to solve for the population. So a group of marine biologists capture and tag 18 whales and release them into the ocean. A year later, they return to the same area and count 92 whales, 8 of which have tags. We want to estimate the whale population in the area. Well, our population this time is what we're trying to find. So what we have are the 18 whales that they captured, tagged, and released. We have the 92 whales that they counted later on, and they have the 8 with tags. Now the tough part is figuring out what's what, because we need to do our successes divided by the sample times our population to get our inference. Now usually we were looking for inference, so we knew success, sample, population were what we were going to get from the story. But that's not always the case. This time we have, their population is what we need to find. We're going to have success, sample, and inference. We need to figure out what's what. Well guys, these 92 whales that they counted, and 8 of whom had tags, that's our sample. That's the survey that they did. So our sample size is going to be those 92 whales that they counted. And the success are those 8 whales with tags. So that means we have these 18 whales left over. The 18 whales that they caught at the very beginning and they tagged. Well, they kind of got those 18 whales from the entire population. Not necessarily from the 92 whales that they counted in that sample, but from the total population. That's the inference. Okay, we are kind of inferring that those 18 whales that they tagged, there's 18 whales in the entire population that have those tags. So now we have everything all fixed, we have everything all figured out, we can sub them into the formula where it goes. So our success was that 8, our sample was 92, our population is what we're trying to find. So let's call that P for population. So 8 over 92 times P equals our inference of 18 whales. So there's our equation, we just need to solve for P. Well, right now, P is getting multiplied by 8 over 92. And what we would do normally is we would divide by that coefficient. But instead of dividing by a fraction, we're going to multiply by that reciprocal on both sides. Okay, which means that this 18 is going to go over 1. Now on the left side, when we multiply, we're going to end up with multiplying reciprocals. They're going to totally cancel. And P is all by itself. Okay, then on the right side, if I do 18 times 92, we'll get 1,656. And if I do 1 times 8, I get 8. So now, I'll take that 1,656, and we know that this division bar, that fraction bar means divide. So we'll divide 1,656 by 8, and we'll get 207. So that's our population size. Now the question's asked with a complete sentence, so we should answer it with a complete sentence. They want us to estimate the whale population in that area. We estimate the whale population in the area to be around 207 whales. And don't forget to circle your final answer. Now guys, we use the same formula every single time. Success divided by sample times the population equals the inference. The only question is, which piece are we looking for? Usually, you're going to be given the successes in your sample. Okay? Sometimes you're given the population, sometimes you're given the inference. But you use the same formula every single time. The only catch is, what variable are you solving for? If you're trying to find the inference, well, good news. It's by itself. All you have to do is whatever's on the other side of the equation. But if what you're looking for is population, well, then you're going to have to do a little bit of algebra to solve for it. But it's the same equation every single time. Success divided by sample times population equals the inference. All right, thanks, guys.